So, in class this week, we have been talking about multi-digit multiplication and becoming fluent multipliers. Being fluent means that not only am I efficient by multiplying correctly and in a timely manner, but I also can use more than one strategy to explain how I got my answer. So these are some strategies that we've worked on this week, and I'm going to start with first a 2-digit by a 1-digit. And then we'll do a little bit more complicated. 2-digit by 2-digit, 3 by 1, or a 4 by 1 is what we'll learn in 4th grade. So first is repeated addition, because multiplication is repeated addition. You're repeatedly adding 26 3 times or 3 26 times. So I'm going to do 26, 26, 26. I'm going to start in my ones, 6, 12, 18. Regroup my 10. 2, 4, 6 plus 1 is 7, 78. Now, I'm going to do arrays. And my suggestion for all my students is when you're multiplying by a 1-digit number, repeatedly adding is the most efficient way. But it can get trickier. So for an array, you have 3 rows of 26, or you could do 26 rows of 3. 3 rows of 26 is much easier to draw. And I'm going to use base 10 blocks, 1, 2, 3 rows, to show 26. So 10, 20, 1, 2, 3, 4, 5, 6, 10, 20, 1, 2, 3, 4, 5, 6, 10, 20, 1, 2, 3, 4, 5, 6. So I'm going to count my 10s, 10, 20, 30, 40, 50, 60. Then I'm going to count my 1s, 6, 12, 18. 60 plus 18 is 78. Now, an area model is very similar to an array model. But instead of drawing out the base 10 blocks or the dots, I can know that 3 rows of 26, this is really 10, 20, so together that's 20. 3 rows of 20 is 60. And I'm going to show that this is 3, this is short, and 20 is very long. It takes up a lot of space, like you saw on the array. And then I have 6 1s over here. That takes up less space. And 3 rows of 6 is 18. And now I have 60 plus 18 equals 78. So an area model is very similar to arrays, except for I'm not drawing all the parts inside, because if my student already knows what 26 looks like 3 times, then they can shorthand and just put the numbers inside the box. And an area model is covering up a space using rectangles. Next is partial products, and that is doing every digit times the other factor. So, 26 times 3. I'm doing 20 times 3 because this 2 represents the number 20. And that's 2 times 3 is 6. And then I move over my 1's place to my 10's place for this 0. And then 6 times 3 is 18. That can add up 78. Now, all of these strategies are efficient when you're doing 2 by 1. However, when you get to, let's say, a 4 by 1 or a 2 by 2, repeated addition becomes less efficient, especially if you're doing 26 times 56. You wouldn't want to add up something 56 times or 26 times. Arrays, let's say I'm doing 1,852 times 8. I wouldn't want to draw out 1,000 of anything 8 times. And for an area model, that one is still pretty efficient. Partial products can be efficient. However, when you do a 2-digit by 2-digit, a lot of students lose some of the numbers. So we're going to talk about how to do partial products and area model together. They're kind of combined using what we call the box method. And I'm going to do a 2-digit by a 2-digit. So I'm going to do 43 times 21. Now, you would not want to add up 43 21 times or 21 43 times. You would not want to draw any of those out for an array model. Area model you could do. Partial products you could do. So this kind of combines both of those. The thing about partial products is a lot of times students will do 40 times 20, but then they will forget to do 40 times 1. Or they might do 30 times 1, but forget to do 30 times 20. So the box method is just a way to arrange your numbers so you do not forget to multiply one digit by a different digit. So first I'm going to do, like an area model, 40 plus 3. I'm going to separate each number out so I know to multiply each of those numbers by the other factor. And then 20 plus 1. So first I expand out my numbers and I draw a box. Each addition sign needs a line. If it's on the left, you go across. If it's on the top, you go down. And it's a 2-digit by a 2-digit, so you should have 4 products. And the inside the window, inside the box, is where your products go. I'm going to change my color so that you can see. So, in this box is, tell my students to go up to outside the box, 40 and over outside the box, so 20. On the outside of the box are all the factors, so that's what you're using to multiply, and your answers go on the inside, your products. 4 times 2 is 8. I move over my 8 twice because I have one spot here and one spot here. That's 800. Then this box, I go up to 3, and I go all the way over to the factor outside the box, which is 20. So 3 times 20, 3 times 2 is 6. I move it over one spot for the tens, and I need a 0 there, 60. This box, I go up to 40, and then I go over to 1. 40 times 1 is 40. And then this last box, I go up to 3, and to the outside to 1. 3 times 1 is 3. Then I add up all my products. 800 plus 60 is 860. 40 plus 3 is 43. Start at the ones. 3 plus 0 is 3. 6 plus 4 is 10. Down my 0, regroup my 100. 800 plus 100 is 900. 903. Now, these are the same answers you would get if you did the traditional algorithm, which your students will learn next year. But learning these strategies helps students to understand the why. For instance, most adults know to do this, and then you put a 0 here. Most people do not know why you put a 0 here. It's because you're multiplying by 20, not 2. However, because they do the box method or the area model, they understand that they're actually multiplying 40 times 20 and 40 times 1 and 3 times 20 and 3 times 1. So that is why we spend a whole year on just the strategies so your students understand how to multiply efficiently and to be fluent in multiplication. So remember you always use 2 strategies. This is a great way to check your work by multiplying with another strategy.